This is the conceptual design of a floating offshore wind turbine. For this, we have relied on nature's design found in the adaptive behavior of the palm trees to high winds. As main advantages over conventional wind turbines, we can advance you the following. This wind turbine can be installed in deep water. It is floating, anchored with wires to the seabed. There are no limitations in the configuration, size or shape of the electric generator. It is at the bottom of the system, underwater, being used as a stabilizing mass. It has an autonomous directioning. Its configuration allows to regulate the balance of position for optimum orientation. Finally, I advance them that the blades can be folded in the case of strong winds. It causes that hold the system has protection. As I was said him earlier, this conceptual design corresponds to a floating offshore wind turbine. Is fixed by wires to the seabed in 3 different points. It is a floating wind turbine, then it can be used in marine areas where the depth prevents the installation of conventional wind turbine with foundations on the seabed. As major components distinguish the mast, the main element that shapes the whole. The mast adopts a curved shape at the top. The fundamental differences compared to other designs, we have that the electric generator is located on the bottom, acting as balancing mass of the assembly. The power is transmitted by multi-axis along the inside of the mast, using conical gears for changing direction between these axes. These gears are also used to increase the speed of rotation on the shafts and thus reduce its section. Therefore, the size, weight and configuration is not affected by any limitation. Impossible on typical configurations. On top, in the bottom of generator is the piece where are anchored the wires. This allows the whole rotate. The mast is cylindrical only at the bottom. At the top adopts a more aerodynamic shape, causing minimal interference in the wind flow, and it adopts a section more resistant to bending. Another component is the float. Its mission is to provide much of the buoyancy to the whole. This piece remains fixed. On it there are the anchors on fixing the upper braces. Allows rotation of the remaining assembly to orient the wind. The float contains a load balancing system to stand upright the mast if varying wind load. About the end of the mast is the diffuser nozzle that takes effect in the wake. They are also the mobile rotor, the guidance system and gloom system of the blades. With this configuration we get the improvements that I have said him at first. Also, the blades can be folded with high wind. It is good for the blades. It allows less need for their mechanical strength and the ability to continue to operate with very strong winds if the blades are partially folded. Because the entire assembly can adopt a low resistance to strong winds and the lower weight of the top, the weight and material characteristics reduced manufacturing costs. In conclusion, as we have said before, we would stress that this prototype is an innovation in the design of offshore wind turbines and can be installed in locations where wind energy are not yet exploited, since current models do not are adapted to the presence of winds and water depths of more than 50 meters. Thus, it could extend to these areas offshore wind turbine implantation, all with lower cost. Thanks for your time.